Okay, chapter 3 review. We'll see what we can do here. One big idea is translations. What's that mean? Well, it means this. If f of x equals x squared, what happens if you have f of x equals x squared plus 2, or f of x equals x squared minus 3? Okay, plus 2 moves the graph up 2 units. X squared plus 2. Minus 3, same graph, slides it down 3 units. Same picture, okay? So up and down, if you have your function and you have plus or minus on the outside. Now, say you had f of x equals the absolute value of x. Here's what that graph looks like. It's a V shape. So this works just like quadratics, but f of x equals the absolute value of x plus 2. What does that do? Well, it moves this graph over 2 units, but when it's on the inside like this, it goes to the negative direction. So f of x plus 2 slides it to the left 2 units. Call it g of x. Oh, that's exciting. All right, x minus 3, absolute value, takes the graph and moves it to the right 3 units. So what you see for the absolute value here works the same for quadratics. Sometimes they'll give you this form of a quadratic equation. This is called vertex form, ax minus h quantity squared plus k. So if you're given a function in this form of a quadratic, and it's quadratic because it's degree 2 here. If somebody says, hey, f of x is equal to negative 2 times x plus 3 squared minus 4, and they say, where's the vertex? The vertex is at h comma k. So you say, what's h? Well, negative h is positive 3, so positive h must be negative 3. And positive k is negative 4, so k is negative 4. Here's the vertex. Does this open up or down? Well, it's negative in the front. So normally quadratics open up like this. If you have a negative, what it does is it'll make the quadratic open down. Okay? So also, say somebody says, do you have is this a polynomial graph? When you hear polynomial, think smooth curve polynomial. So if you have sharp points, it's not a polynomial, okay? Quadratic equation is a polynomial. The absolute value one that we had was not, because it has a sharp edge there. Polynomial, smooth curve, okay? If somebody says, hey, f of x equals x to the third minus 4x to the fourth plus x to the seventh, and somebody says, what's the degree of this polynomial? Well, the degree is, if you had this in standard form where the highest power was first, the degree is the degree of the leading term. X to the seventh has the highest power, so the degree of this polynomial is 7. Okay? So say somebody gives you something like this. F of x equals x to the third minus x squared minus x plus 1. One thing, list all possible rational zeros or roots. They could call it either thing. This is where you say, hey, what are P and Q? What are the factors of P? Plus or minus 1. What are the factors of Q? Plus or minus 1. So all the possible ones would be P over Q plus or minus 1 divided by plus or minus 1. Not very exciting here, kind of easy. This would just be plus or minus 1. So aside, let's go like this. If you had f of x equals 3x squared plus 2x minus 1, the possible factors there, P over Q, would be plus or minus 1 divided by plus or minus 1 and plus or minus 3. So something like this, it has a few more factors. Positive and negative 1 over 1, which is 1, and positive and negative 1 over 3, 1/3. So there's 4 possibilities of roots. Roots are solutions to this that are rational. Okay? List all the possible roots. So then you're going to have something like this. Find a root. Find a root. So you only have 2 choices, positive or negative 1. So the way we do this is we do synthetic division. 1x to the third minus 1x squared minus 1x plus 1. And with these 2 choices, let's just try 1. You bring the first term down, 1 times 1 is 1. You add 1 times 0 is 0. Bring it down, negative 1. 1 times negative 1 is negative 1. Okay, so you have 0. So if you had x to the third minus x squared minus x plus 1, and you found 1, 0 was x equals 1, there's 1, 0. The other zeros, you rewrite this and you say I had to the third, now it's x squared. Now that's plus 0x minus 1 equals 0. To find the other 2 roots, we're going to factor. Okay, this one factors pretty easily to x plus 1, x minus 1. So the other zeros are x equals negative 1 and x equals positive 1. So what are the possible zeros? Find a zero, find a root, find a root. Sometimes they say find a 0, means the same thing. Factor to solve. What is the new equation? Like the old equation was this. What's the new equation? It's x squared minus 1 equals 0. And so you have this, guys. You have the zeros are at negative 1 and positive 1. The multiplicity of negative 1 was 1. The multiplicity of 1 is 2. So the behavior of your graph, if you have a multiplicity of 1, the graph goes through 1. So, and if you have a multiplicity of positive 1, it turns around. Sorry, if you have a multiplicity of 2, if you have an even multiplicity, it turns around. I was thinking about something else. So here's your picture. You have a 0 at negative 1, you have a 0 at positive 1, okay? Now the original graph was odd, and that told you the graph rises to the right, falls to the left. Now at negative 1, it has a multiplicity of 1, so the graph goes through. The y-intercept, if you put a 0 into this thing, it equals 1. So the y-intercept is here, so it goes through to here. Now the graph comes down, and as you can see, it goes back up. So at this point, it's going to turn around. Why does it turn around? Because that's a double root. The multiplicity is 2. If the multiplicity is even, the graph turns around. If it's odd, it goes through. So last thing, probably, end behavior of a graph. End behavior. If your graph is even, equals x squared. Rises right and left. If your graph is odd, the line y equals x rises right, falls left. Lastly, a negative out front switches everything. So if you have y equals negative 4x, let's say to the 4th power, that's still even. So normally that would rise right and left, but the negative 4 makes it fall to the right and left. And if you have y equals negative 3x to the 3rd, normally this rises right and falls left like this. But instead, this rises left, falls to the right. Sloppy writing. But the negative switches everything. I think that should do it. Thank you guys.